and gentlemen, welcome back. I hope your break was good. We're just going to get right into it today, but last week we talked about this formula here, and I'm just going to break it down for you a little bit more, just to expose you to it again, because I don't feel like we spent enough time on it last week. So take a second, look at the formula, and think of some things that each of these variables mean. They all mean something different, and I'm going to tell you, but I want you to try to think about it on your own for a second. So we'll start with the M. That's one that we hit on. What does the M mean? It is the slope, or we can call it the rate of change. And we will get back to that in a little bit. Slope or rate of change. So when we have a line on a graph like this, and let's say it's like that, our slope is, remember, it's rise over run. So rise, run. Whoops. There. So it's 1, 1. So our rate of change would be 1 to 1. Now, if this line was like this, okay, we would rise 2, run 1. So rise over run. So our slope would be 2 over 1, or that's our rate of change, is 2 over 1. Okay, we'll hit that a little bit more in a minute. B, what does B mean? B is the y-intercept, or our starting point when we graph an equation. So what I mean by starting point is if we have y equals 2x plus 3, 3 is our B, and that's where we'll start our graph, which is right here, because it's the y-intercept, which is this right there. I just scribbled. So this is our starting point, and then we can graph our slope, which if we look here, what's it going to be? It'll be rise 2, run 1. Boom, that's our next point. Rise 2, run 1 puts us there, and then if we want to go this way, we would just invert it. So we rise down to left 1. So that our line stays a line. So that just tells you what B means, and that's what I mean by our starting point, because that's where we will start the majority of graphs when we graph a line. Okay. Next, we've got X and Y. So X, that is our input, and Y, you may remember, is our output. So back to this equation, y equals 2x plus 3. If we input the number 0, so if our x is 0, I'll draw a little table. So if we input 0 into here, 2 times 0 is 0. So that gives us y equals 2 times 0 plus 3. Well, we know that 2 times 0 is 0 plus 3, which means that y equals 3. So this is our output. So we can put that there. So we know that when x is 0, and remember this is our x-axis, this is our y-axis. When x is 0, our y is 3. And we can do that for all of our x values. So if we say that x is 1, which will be right here on this part of the grid. X is 1, that makes it y equals 2 times 1 plus 3, which equals y equals 2 plus 3, which equals 5. So this is our output when we input the number 1. We get 5 for y. And so we're working it. So this is x0, 1, 2, 3, 4, right? So if we input 1 for x, then so this is 5, 4, 3, 2, 1, 0. That's the y-axis. If we input 1, we get 5 for our y. And then you can imagine what 2, if we input 2, we'll just do it real quick. Because it'll be... I want you guys to guess what the output's going to be based on our line so far. You guys know that it's going to rise 2, run 1. So you can guess it's going to be there. I'm going to show you why. So we input our 2, which gives us y equals 2 times 2 plus 3. Y equals 2 times 2 is 4 plus 3 still. So y equals 7. That's our next output, which is that point right there. So that's the method of using the table to plug it in. I'm sure you guys have seen that already, and if you need to go back and look at, pause the video, look at something, feel free to do that. But all right, we're going to move on. So that's those points, and that's what those terms mean. So yeah, output y, slope or our rate of change is m, x is our input, and b is our y-intercept or our starting point. So with this table right here, I want you guys to, you can just use your pencil or your finger to point on the graph where you think the points are going to go on the screen, or you can draw out your own graph. Whatever you choose to do is fine. But here is a table of values. These are our inputs. These are our outputs. And I'm just going to graph them very quickly. So if this is negative 1x, 0, 1, 2, 3. The y-axis is always 0x. So we know that at 0x we have 4. So that's where we're going to start our graph. And actually I'm going to back up there. There we go. And then at negative 1x we have 3. So we'll go 3 here. And at 5, or at 1x we have 5. So that'll be right here. At 2x we have 6. And so on and so forth. Okay? So here's our line. And what we're going to do is we're going to write an equation for this. So the first thing we write when we're writing a formula is with the slope form is going to be y equals. And now we have to figure out what's some things we can figure out here. We still need to write our mx plus b. But remember, in a slope formula, the y and the x always stay as y and x. So we don't really need to find x, but we need to find m and b. So what's our plus b going to be? What is that value going to be? If you remember, it is called the y-intercept, or our starting point, which is this right here. Or I guess circle there. So that's 4. So it's going to be plus 4. And then m, so we know that x is there, right? And m is our rate of change or our slope. And so if we look here, our rate of change is rise 1, run 1. Rise 1, run 1. So it stays consistent throughout. That we're rising 1, running 1. Rising 1, running 1. Which our rise over run is this, which equals m, which also just equals 1. So we can throw a 1 here as our m to represent m, and we'll just do that for now. But technically, we can just leave it as x. Cool. And then something new that we're introducing is whether it's linear or nonlinear. So if you look at the word linear, you can think of it as line. So if our graph is a straight line, then it is going to be linear. If it's not a line, it's not linear, and we'll get into more of that. We won't hit them too much, but you'll see graphs that look like this, that have kind of like a curve, or like this. It's like a U. Those are called exponential functions, like y equals x squared, because if you plug in numbers like, if you plug in a 1, input a 1, you'll get y equals 1 squared, which equals y equals 1. So then 1, 1 would be this. And you plug in 0, it'd be 0 squared, and 0 squared is right here. And then if you plug in a 2 as your input, you get y equals 2 squared, which equals 4. So at x equals 2, it becomes 4, which causes it to curve, which makes it nonlinear. So that's just an example, but that's what we mean by linear and nonlinear. So this one is linear. All right, we're going to graph another one. And remember, you can pause the video if you need to and look back at things. But we're just going to keep on chugging. There we go. Perfect. All right, now we're going to graph this blue one together. I'll just show it to you. So this will be a nonlinear graph. So right here, our input is -2, which is right here. But our y is 4. All right, and then -1, we have 1. So at x value -1, which is this way, we have y value 1, which makes them meet there. Okay. 0, 0, 1, 1. At 2x, we get 4. So that'll be right there. And then we can extend it some more. At 3, it goes up to 5, 6, 7, 8, 9 right there. So this is just an extension of that formula I just showed you. Wow, those lines are not good. And then it just keeps going up. So that would be nonlinear, and the formula for that, like I said, is x squared, nonlinear. Okay. So if you're struggling with this, I would encourage you just to look back over the video and just restart it, because this is an important concept and it will make sense the more you are exposed to it and can think about it. But remember, with this equation, we'll go with this one. Technically, it's going to be x squared plus 0. 0 is our y-intercept right here. But if there's no plus 0, you assume that it's right here, because we don't have to have plus 0 there. So sometimes you'll see an equation like that. All right, next one. I'm going to graph these, but what I want you to do is fill in the blank here and guess what you think that value is going to be. And I'm going to write in the values here. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. All right. So these are just the y values and the x values for the lines, just for a visual. Okay. So at 0, we get y equals 4. At x0, we get y4. At x1, we get y3. x2, you guys are going to have to answer that. And then x3, we get 1. So where do you guys think the next point's going to be? You can point at the screen or something. I'm sure that you'll get this one, but it is going to be right there. And that makes our line like this. And it just continues this way, all the way, all the way. Okay. So that's our line. And what I want you guys to do is try to write a formula for this line. So you can pause the video and start the formula. Okay. I'm going to write it. So it's y equals, our slope is down 1 over 1. So our rise is technically negative. Negative 1 over our rise is negative 1, and our run is 1. And then x plus, where does it cross the y-axis? 4. And a way that we can simplify this is we know that negative 1 over 1 is equal to negative 1. So we can put negative 1 in front of our x, negative 1, which we know that negative 1x is also just equal to negative x. So we can just get rid of this one. And there you have it. Okay. And is this one linear or nonlinear? It is linear. Wonderful. Okay, our next one is going to be blue. I'm not going to erase the old one, so we're just going to have to work with it. So at 0, our y is negative 5, so we go down 1, 2, 3, 4, negative 5 right there. Okay. At 1, it is negative 1, so x1, y, negative 1 is going to be right there. x2 is at y3, and where is x3 going to be? So what point is, where is it going to be? I want you guys to figure that out. And this has to do with our slope or our rate of change, which is between these numbers. So what's the pattern you see? If you said adding 4, you'd be correct. So each time we move this way by 1 value, so x, as x increases, 1, 2, 3, 4, each time there is a gap of 4 in between these. So from negative 1 to 3, there is a gap of 4. From negative 5 to negative 1, there's a gap of 4. So that means that this is going to be the number 7, which is right here. I already graphed it. And that gives us this line, which is linear. We can see that pretty clearly. And now we're going to write our formula. So I want you guys to try to write the formula again. Do your very best, and then I'll show you the answer. So remember, first you want to start with your y-intercept, and then figure out your rate of change, or your slope. So our y-intercept is negative this time, and it's negative 5, because where it crosses is at negative 5. Okay? And we always are going to have x there, and we need to figure out what our slope is going to be, or our rate of change. So we know that it rises 1, 2, 3, 4, and runs 1. So rise over run is 4 over 1, which gives us y equals 4 over 1x minus 5. But we know that 4 over 1 equals 4, so we're just going to write 4 here. 4x minus 5. All right, there you have it. So this is just different ways that you can write a function. So this is one way we talked about, is table form. You can graph the function, which is another way to represent it, or you can write a formula, which is a third way to represent it. And you're going to need to know all 3 ways. So, and remember, if you want to rewatch this video, feel free. It would be helpful for you. Okay. So this on the right is going to be a funky function that you guys haven't seen before. So we got 0, 0, 1, 1, 1 or 2, and 1.41, which is, we'll say it's about right there. And then 3 is 1.73, which is about right there. 4 is 2, and 5 is 2.23, which is about right there. So there's our function. Not the perfect line, but approximate. So is this linear or nonlinear? Is it a straight line or is it not a straight line? It is not a straight line. And the formula for this one is going to be y equals the square root of x. Because when we plug in 0 to our input, x, that gives us y equals square root of 0, which we know is just 0. I don't know if you guys have worked with square roots yet. I think you have a little bit, but this is a new concept, so it's okay if... The only thing I want you to really glean from this is that it's not linear. So y equals square root of 1 just equals y equals 1. And you can plug this into a calculator. If you do y equals square root of run, these are the values you'll get for each of these numbers. So y equals square root of 2 will give you 1.41. So that's input gives you the output, or y. Okay. And this will be our last one right here, this blue one. So we've got at 0, it's -5. Oh, did we already do this one? We already did this one. I'm going to switch it up. Okay. We will make it at 0, we get 2. At 1, we get 0. At 2, we get -2. So what's our 3 going to be? So first point is going to be where? Just point to the screen and watch the dot magically appear. Boom. There it is. Next point to where it's going to be and watch the dot magically appear. At x is 1, we get 0. And then at x is 2, point where the next point's going to be, watch the dot magically appear. Wow, you guys are magicians. And then the third one, where's that going to be? At x equals 3, it's going to be -4. So can you guys see that the rate of change is we're subtracting 2 each time? So the rate of change is -2. -2y per 1x. So can you see that we're subtracting 2 here, subtracting 2, subtracting 2. From 2 to 0, we subtract 2. From 0 to -2, we subtract 2. From -2 to -4, we subtract 2. So our rise is -2, and then our run is just 1, because each time we increase by 1. So our run is 1, which gives us -2 over 1. And you can see that represented here in our graph, which says rise is -2, run is 1. Boom. Rise is -2, run is 1. Boom. And it just continues, and it goes that way too. So, oops. We know that y equals, and we just gave you the rate of change. This is how you can tell in a table what the rate of change is. And this is how you can tell on a graph. You can measure the rise or in the run. And if the rise is positive, you would keep it positive. So if it went this way, it'd be up to, right to. But in this graph in particular, it is negative. So we have -2, and it's technically -2 over 1, but we can just write it as -2. And that tells us that the rise is -2 and the run is 1. And then our x comes next. And then where is our y-intercept? Where does it cross? Where's our starting point? Well, we started with y equals 2. Oops, I just backed up. So, at x is 0, y is 2. And a trick to figure out the y-intercept based on the table is whichever x value is 0, whichever output that gives you, that is your y value. So that's just a little trick. And then is this one linear or nonlinear? It is linear. So I'm going to actually give you a formula that I want you to graph. And I want you to tell me if it's linear or nonlinear. And what I want you to do is I want you to make a table, X and Y, of your inputs and your outputs. And I want you to try different numbers. So here's the formula. We'll do 3x minus 2. Okay? And what I want you to do is first plug in some values. So you can start with 0. So your input is 0. I'll just give you an example for this one, and then you can do the rest. So your input's 0, so you'll throw 0 in instead of x. And you got to make sure you put parentheses because you're multiplying 3 by 0. Because here it's technically 3 times x, right? And then you're still subtracting 2. So that tells you that y equals 0 minus 2, which means that y equals minus 2. So that is your first value, which will give you a starting point for your graph. So this is a little bit off. So if this is your graph, where would your starting point be for the graph? It's going to be right there. Whoops, I didn't make a dot, but at x is 0, negative 2. So I want you to do the values, x values. I want you to do 1, 2, and 3. And I want you to plug your input into the formula for each of these values separately. So you'll have, for one of them, you'll have y equals 3 times 1 minus 2. And then you do a whole separate one for 2. Does that make sense? If that makes sense, go for it. And then draw a graph and bring it in with you to class tomorrow. All right, that's it for today.